Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com, and we'd love to talk to you about hosting your telescope under our dark sky. The last video we looked at how to use smart objects on this image of the elephant trunk to apply sharpening, apply some noise reduction, and just generally clean things up. Today we're going to continue using the power of those smart objects and look at how we can add new data to this image from another couple nights of data collection. And we'll be using smart objects and a little bit of PixInsight right now. So to start with, let's switch to PixInsight. And I've already got WBPP open. It's the weighted batch preprocessor. And I have it configured now with multiple nights of data. The first image that we were looking at just had one night. I think it was around 3 or 3.5 hours of data on the elephant trunk. I went back for 2 more nights. So now I have a total of about almost 11 hours of data. And if we look at our lights, you can see that we've got more hydrogen, more oxygen, and more sulfur. And typically what I would do is the first night that I'm imaging, I'll capture narrow band plus some red, green, and blue for the stars. And here there's really, very little. There's 3 each at 5 minutes of blue, green, and red. But that's enough to give me good stars. So for the next 2 nights, I really focused just on narrow band and took the red, green, and blue out of the sequence. So what I was adding was just the narrow band data. So in terms of setting this up, I went through the plus lights and added data from each one of the nights. So here I had the 14th, 15th, and 16th. And then in calibration, I did my usual configuration. I set a pedestal value of 300 and applied that to all light frames. The main thing you want to do when you're adding data is we want it to be registered the same way, which means if I just run this with automatic registration selection for the reference image, I don't know what image it's going to choose, and the registration will probably be different. And keep in mind, I'd never crop an image until it's completely done. So as long as I use the same image for reference, the same frame, then everything will line up and I can just add this data to what I've already been working on without having to worry about realigning things. So what we're going to do is choose manual as the registration mode, and then that enables us to select exactly what file do we want to use for reference. And to find that, what we'll do is I'll go into the Explorer on Windows or Finder on a Mac, and we want to go to the folder where you have your swap files. And in this case, I have the elephant trunk swap files. Open that up, and you can see there's, this is your master where your work finally appears. But there's also one for logs. So if I open the logs folder, and let's just open the most recent log file, and it just opens in a text editor in Notepad on Windows. And what we're looking for is the word reference. So I can do a Control F for find, look for the word reference, and that takes us right down to begin selection of the best reference frame. And we can see that the frame that it's selected was red. So and we know it was something that had to come from the first night. And the one it chose was number 991. So we're looking for red 991. And it's actually taking it out of the calibrated folder. So what we want to do is we want to navigate to the calibrated folder. So we'll go to the D drive, to the swap files, to elephant trunk, to calibrated. And we want the red calibrated files, and we want red 991 right there. So click open, Now we're forcing PixInsight to use the same reference image that it used before. So all the stars, all the nebula, everything is going to line up just like it did the first time through. Only this time we're integrating almost 11 hours of data rather than just 3 hours of data. So at this point, we would click Run. It would go off and do its thing, and it's already done that. So I'm going to just exit out of here instead of running it because, as you could guess, I've already actually run this. My next step, obviously, is to do the same thing we did in the speed run, and that's to open. We've already done the stars, so I don't need to do those again. So I would focus just on the hydrogen, oxygen, and sulfur. So we would go to sulfur, hydrogen, and oxygen, open those, and then go through each one of these using the usual processing of usually I don't use dynamic background extraction on the monochrome data unless it has a real obvious gradient of some sort. These don't, so I would go straight to Blur Exterminator, stretch it with the screen transfer function, and modify it before I copy it to the histogram to apply it. Apply Noise Exterminator and Star Exterminator, but I don't need to save the stars, and then save each one of those results as a 16-bit TIFF. Then we go to Photoshop, and we actually just start by reopening the image that we just worked with. And if you recall, we spent a fair amount of energy creating these layers into smart objects. So the original data, and let's start with sulfur, the original data is inside this, is actually a nested smart object at this point. And what we want to do is just replace that bottom source file with new data. And so to do that, first we need to open the files that we just created. So I'll go to File, Scripts, Load Files into Stack. That brings up this dialog box where we can browse to locate the files that we want to use. And I have those saved in the elephant trunk data. And I almost always keep my directories sorted in descending date sequence. So the newest ones are right there on top. We'll select those, click OK. It opens those as individual layers in a document. And we can see right away our orientation is different. So we'll need to rotate this 90 degrees counterclockwise. And of course this rotates the whole image, not just a single layer. So now the orientation matches, and because we used the same reference image, everything else matches too. So now let's go with this, start with the sulfur. And if you recall, when I double click on this smart object, it will open the underlying source data. So we'll double click on that. And if you recall, this is a nested smart object. So there's the smart object where we applied the smart sharpen. So we'll double click on this again. Now we're back to the base layer, and this is what we want to replace. And so what I'll do is just come back over to the one that we just loaded as a stack, select the sulfur layer, and tap V for the move tool. This is a little bit tricky. We could do a Control A, Control C, Control V to copy and paste. I tend to like to just drag and drop, but it takes a little practice. What you do is you click the one you want to copy from and hold the mouse, drag it up to the tab where you want to copy it, continue holding the mouse button down and drag it down into the layer. But we want to drop it in exactly the same place it came from. And the way we tell Photoshop to do that is by holding the Shift key down and then release the mouse. And you can see now we have added our new and improved sulfur layer right on top of the old one. And of course it's in exactly the same place. And you can see the benefit of having more data. There's quite a bit more detail there. So we don't need this one anymore, so I'll just click on the trash can to delete the original. Now you can see that we have the sulfur mono with the 2 in parentheses. So this is the number 2 version, actually the 3rd version. When I close this, if you recall, when I click on the X, it will say, do I want to save it? I say yes. It saves this back into our smart object where we're applying the smart sharpening filter, which is what it's doing now. And so there it is. The filter's still there, the mask is still there, everything's still the same, it just has new data. We'll close this, say yes, and this is going to save it back into our original document with the dust and scratches filter and the noise, add noise, and we can see it's a little bit brighter than what was there, so we'll just adjust the brightness, and now we have more sulfur data added. All of the other work that we did is just carries through. It's already done for us. The stars are already done just the way we liked them before. All we've done is update this smart object to have in total almost 11 hours of data instead of just 3 hours of data. So we'll just do the same thing with the oxygen. I'll double click on the oxygen smart object. Double click on that nested smart object to open the original file. Come to the file that has just the oxygen. Again, we have this glow, so we might want to fix that with the this time we'll use just the healing brush. So grab the move tool, drag this over to that what's going back into the smart object. So here's our original, here's our new one. We'll delete the original. We'll click the X to close this. So this is applying the smart sharpen to the image. Now it always goes back to the last or the previous tab that you used, which is the this untitled one that has the 3 stacked. And we actually want to go over to this one, which is the smart object. We'll close that, say yes, and so now it's updating the oxygen within our master document with the new data. And there it is now with some additional oxygen. And again, we may find that we need to tweak the brightness a little bit. I don't put a lot of energy into fine-tuning the stretch in PixInsight because I know I'm going to adjust it in Photoshop. So let's just quickly do the hydrogen. We'll open up the layer. This time it's not nested. We'll go to the oxygen, or I'm sorry, the hydrogen layer, drag, go into the image area, hold the shift key, release, delete the old one, close this, say yes, we want to update, and again this is going to be brighter. We could see that there's a little bit more data, a little bit more detail, and it's overall a little bit brighter, and that may have just been the mood I was in when I did the stretch. So we'll come back here. Again, we may want to adjust the overall brightness of the hydrogen, but I would say that looks pretty good. We might want to adjust the global brightness down a little bit. Now that we have more detail, we get a little bit better sense of what the color is going to look like. So, this color layer is probably going to be a little bit more revealing. We may want more or less saturation, just depending on how we loaded things in. And so now we have our new and improved image that started out with 3 hours of data, and we've just added the updated data so that we have, 10 hours and 45 minutes, or almost 11 hours of data. So we get an overall much cleaner image than what we started with. So smart objects are extremely useful. They can save you a lot of time, and they also give you a lot of flexibility in how you approach your editing. Because they're very much non-destructive, we can save this document as a .psb. This is going to be a large document, but we can come back tomorrow, next week, next month, next year, all of these same tools are still available to us. We could update the data again if we had the same reference frame available. We can change the color, we could change the sharpening, the noise reduction. If we find a satellite trail that we missed and we need to clone out, again, we can always go back to the original file layer, edit that, and save it back into the smart object. So I like to say that time is the most important ingredient in astrophotography. Certainly integration time is important, that's obvious, but editing time is important too, and things you can do to speed up your editing workflow for the things that are just kind of turning the crank gives you more time to spend in your editing workflow being creative. And that's ultimately going to lead you to better images and better results and probably more satisfaction. So I hope you found this useful. If you have any questions, drop them in the comments below. And if you like this kind of content, feel free to like the video and subscribe to the channel, because there will be more coming along. And with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.